Neil deGrasse Tyson said, "We have universes in obscurity ages that ought not to be there. So what's going on? Is the information wrong? Or are our speculations wrong?" A difficult issue has arisen. The James Webb Space Telescope is showing us that there are objects in the detectable universe that are older than the actual universe. This can be seen in the telescope's pictures, where we see lines and lines of systems that, if we follow the old standard models of physical science and cosmology, probably formed long before the Big Bang. One thing is presently sure: we have an imperfection in the framework. Potentially, all that we pondered the universe and all that we determined is wrong. Anybody who adores the universe, the limitless secrets of the universe, and the science encompassing these secrets is presently experiencing an astonishing time. Never before have we had so much proof that many of our old speculations are off base. They must be off base since the Webb telescope is plainly showing us things that shouldn't exist as per these speculations. We're at the start of a new perspective, and it's conceivable that our perspective on science and matter will change totally. Indeed, the most seasoned system found by the James Webb Space Telescope is called JWST 13. This universe existed around 330 million years after the Big Bang and is one of the earliest and farthest known universes. The world was found as a feature of the JWST Advanced Deep Extragalactic Survey, JADES for short. With this program, analysts are attempting to explore the universe as it was in the initial 100 million years after the recently accepted Big Bang. It is a supernatural occurrence or a senseless fortuitous event that we can observe the universe as it was before this long time. Light takes time to travel through space, and today, because of cutting-edge advances such as the James Webb Telescope, we can see light that has been traveling through the universe for millions or billions of years. With our telescopes, we generally see an engraving of the past. Even the light from our closest neighbors requires years or many years to contact us. It is a fortunate turn of events that we can see cosmic systems like JWST 13 and thus are ready to figure out the beginnings of the universe and explore these far-off times. However, maybe the universe is built in this way exactly because we are meant to explore it. Maybe it's the actual universe that has made itself along these lines. If so, then the universe is pulling a prank on our scientists, or it is saying, "Hey, you didn't look carefully." Maybe some intelligence in space is presently ridiculing all the Earthlings who, like Neil deGrasse Tyson, are thinking so hard nowadays about the universe, its beginning, and the advancement of matter. Cosmic systems in obscurity period that can't be there should make us pause for a minute to think about how researchers have envisioned the universe up to now. There should be a single starting point at which a vague potential was formed all at once. That was the Big Bang. From that point forward, the universe has been expanding into something said to be just uncertain nothingness before the birth of the universe. The universe is endlessly expanding as the universe extends. After the Big Bang, there was apparently just something like a very hot primordial substance, a wobble of gases, heat, and free particles zooming around. Although the universe had already cooled off impressively in the initial moments, it took a few hundred years for the first solid pieces of matter to form. Until a moment that scientists consider reionization, the universe was a dark, impenetrable place. A change in the molecular structure eventually made the universe porous to light. This moment coincides with the birth of the first stars in quite a while, since it was the main stars that ionized the encompassing hydrogen gas and consequently illuminated the universe. Past estimations have shown that the universe was probably about 1 billion years old at this point. However, the system JWST 130 currently existed around 330 million years after the Big Bang, and it isn't the only one. These pictures stunned everybody. It is incredible the number of old systems that were viewed on Webb's first deep images, dozens, and some scientists are discussing hundreds or even thousands of universes like JWST 13 that existed so near the Big Bang that they shouldn't exist. Universes of this size and glow require billions of years to create. As Neil deGrasse Tyson said, some scientists expected that after the first estimation results, the new telescope was faulty. However, more and more examination groups have been able to affirm the outcomes, showing that Webb was working perfectly. The telescope simply wasn't showing scientists what they expected to see. The universe was brightly lit at a supposedly dark time and possibly occupied by as many worlds as there are today. Since these stunning insights, there has been a significant crisis in cosmology. Scientists who have long questioned the Big Bang welcome the new realities, while others are near despair. Even more incredibly, JWST 140 existed 290 million years after the Big Bang. Although the presence of these systems has not yet been formally confirmed, it's sure it's not the oldest cosmic system in the universe. Some examination groups have reported the discovery of systems with redshift values of 20 and possibly more. JWST 140 exposed other fantastic things. The galaxy is more than 1,600 light-years across, and its brilliance isn't caused by a very large black hole, but by young stars. This perception is intriguing because the world clearly contains many young stars. However, there are too many of them, and they are too intricately organized for us to see real baby systems that correspond to the old cosmological perspective. The main universes ought to be wild clusters of stars, not perfectly organized worlds. Specialists are faced with an unsolvable riddle when it comes to shape, particularly because complex shapes like spirals, disks, and other forms are probably made by countless mergers of smaller star groups. No sooner have specialists come to terms with this shock than the following incredible galaxy candidate comes along. JWST 41 is as youthful or old as its sister universe and demonstrates that there are even more old galaxies out there. This raises the question of what scientists will do with all these outcomes. Right now, they are still researching, and the age of these worlds must be confirmed by several research groups before the discovery can be considered official and genuine. Some researchers have already worked on new scientific models and introduced updates to old theories. Canadian scientist Render Gupta has possibly shown that the universe could also be 26.7 billion years old if we change a few values and consider the elements of Newtonian physics. Others, like scientist John Mather, who is also the project head of the entire James Webb mission, believe that the explanation lies in a previous development of stars. Mather posits that we need to address our image of when the first stars and universes were formed. But could it really be that the universe simply shot stars into space in a huge birth and then organized them perfectly? We know of so-called starburst galaxies that produce a very large quantity of stars in a short time, but these galaxies are exceptions and can't have been the norm in the early universe. This leaves the idea that the universe is limitless and that there was never a beginning. How did scientists come up with the Big Bang? By and large, we have two scientists to thank for the old standard picture of the universe: the American Edwin Hubble and the Belgian Georges Lemaitre. Hubble explored the first newly found galaxies during the 1920s, which was as exciting a time as we are experiencing again today. Before that, humanity thought that the Milky Way was the universe. It must have been stunning to see suddenly beyond the edges of the Milky Way, with steadily improving telescopes, and discover more and more galaxies. The world changed suddenly then. Hubble studied the newfound galaxies and was surprised to find that galaxies farther away from us were moving faster. This is how Hubble first discovered the expansion of the universe. The Belgian priest and scientist Lemaitre found evidence that the universe was created by an event and is not boundless. He put one and one together and came up with the idea that the universe has been drifting apart since the Big Bang and is consequently getting bigger. How long ago this Big Bang happened has been calculated several times, and the figure has also been amended several times. However, it has always been in the order of 13 to 13.8 billion years. We may have committed an error here. Render Gupta's calculation shows that other approaches are also possible, and science must now face these groundbreaking ideas. So, a long time ago, we experienced a revolution similar to the one we are experiencing today, and this commotion is probably not the last one that science will encounter. Who knows how many people will see or experience the universe in another 100 or 1,000 years? Will we ever know the full truth? Some scientists are sure that the universe is completely physically and mathematically understandable and describable. Others believe that the universe could be so alterable and so grand that we could never fit it into specific frameworks or formulas using our scientific methods. Webb's observations show that there are other previously unknown types of energy or matter in the universe. It's possible that quantities and physical phenomena change with the passage of time. If so, our chances of understanding the universe through measurements and numbers are slim. What remains for us, anyway, is to explore space as we see it today and to do so as fairly as possible. Our science has reached an impasse now, and a completely new era is unfolding, which we will continue to follow with excitement. The discoveries from the James Webb Space Telescope, JWST, have raised significant questions about the nature of our universe and challenged established theories in cosmology. These discoveries not only expand our understanding but also confront us with the limitations of our current models. Here are a few areas where JWST's observations might lead to rethinking. 1. Early universe and galaxy formation. JWST's observation of galaxies like JWST 13, which existed around 330 million years after the Big Bang, suggests that galaxy formation occurred much earlier than previously thought. This implies that the processes leading to galaxy formation might need to be reevaluated. 2. Cosmic chronology. The potential existence of galaxies older than the currently accepted age of the universe, 13.8 billion years, suggests that our understanding of cosmic chronology might need revision. This could involve rethinking the timeline of events post-Big Bang or even questioning the Big Bang model itself. 3. Nature of dark matter and dark energy. Observations indicating unexpected behavior in the early universe might point to new forms of matter or energy, or alterations in the behavior of dark matter and dark energy over time. This could lead to a fundamental revision of our understanding of these mysterious components of the universe. 4. Redefining cosmic distance and expansion. If JWST finds more instances of galaxies with high redshift values that shouldn't exist, this could imply that our methods for measuring cosmic distances and understanding the universe's expansion need refinement. 5. Star formation and stellar evolution. The discovery of galaxies filled with young stars shortly after the Big Bang challenges our models of star formation and stellar evolution. This might mean that stars formed and evolved differently in the early universe than they do now. 6. Reevaluation of physical constants. If there are changes in physical phenomena over time, as some observations suggest, we might need to reconsider the constancy of physical laws and constants. This could have profound implications for all of physics. 7. Alternative cosmological models. The anomalies observed by JWST might revive interest in alternative cosmological models, such as steady-state theories or cyclical models of the universe. These models could provide different explanations for the formation and evolution of the universe. 8. Quantum gravity and unified theories. The discrepancy between observed phenomena and established theories might prompt the development of new theories that integrate quantum mechanics with general relativity, potentially leading to a theory of quantum gravity. In conclusion, the JWST is opening new windows into our universe, prompting us to reconsider and refine our scientific models. The discoveries challenge us to look beyond established theories and explore new ideas, leading to a deeper and more comprehensive understanding of the cosmos.